Magnesium is a metal that burns easily in air with a bright white light, and this makes it good to use in distress flares and fireworks. We can say that magnesium is a reactive metal. Magnesium's behavior is the opposite of a metal like gold. Gold is a very unreactive metal. It can be dug out of the earth as a pure element. Gold does not form compounds easily. Observing what happens when metals react with water, with acids, and with oxygen in the air helps place them in the reactivity series. Metals reacting with water form a metal hydroxide and hydrogen. Metals reacting with acids form a salt and hydrogen. Metals reacting with oxygen form a metal oxide. A more reactive metal will displace a less reactive metal from a compound of the less reactive metal. Here's an example. It's actually the thermite reaction. Aluminium added to iron oxide will form aluminium oxide and iron. This type of reaction is called a displacement reaction. It takes place because aluminium is higher than iron in the reactivity series, and it can displace iron from a compound of iron. Let's have a look at this reactivity series and ask ourselves the question, do you think if you started off with copper and zinc sulfate, you would get a reaction? The answer is no. No reaction happens. Nothing happens because the copper is not reactive enough to displace the zinc from a solution of zinc sulfate. You should be able to make predictions about whether a displacement reaction will occur based on each metal's position in the reactivity series. Displacement reactions tend to release energy to warming their surroundings. In general, the greater the difference in reactivity between two metals in a displacement reaction, the greater the amount of energy lost to warming the surroundings. So, to summarize, in the reactivity series, the most reactive elements are placed at the top and the least reactive elements are placed at the bottom. You should be able to use a reactivity series to predict whether a displacement reaction takes place or not. A more advanced idea for you to think about is that more reactive metals have a greater tendency to lose electrons and form positive ions than less reactive metals. Why not produce a mnemonic to memorize the order of the reactivity series? A favourite of mine is, please send camels money. All caring zoos in lockdown have cut spending greatly, people. I hope you've enjoyed the video. Please subscribe to the channel. Your support is most appreciated. Thank you very much and good luck with your learning.